hope you find you well. This is a quick reminder. Before we start, I want to remind you that who hasn't sent the portfolio projects, the deadline is on Wednesday. 4 weeks was more than necessary to prepare them. If it is already prepared, send the PowerPoint via email or via your teacher. If it is in cartons, make a photo of the project and send it. Thank you. Now, the revision is the oxidation and reduction reactions. As you already know, next week there will be an exam, so these two lessons, the first part will be the basic chemistry, that we're going to do the revision, and the next hour we're going to do the elective one because the exam will be mixed. Now, as we know, redox reactions are chemical reactions involving simultaneously oxidation and reduction processes. The oxidation and reduction are addition or loss of the oxygen or hydrogen, accepting or donating electrons, change in oxidation number. Redox reactions. Oxidation is the process of gaining oxygen and the elimination of hydrogen. Reduction is the process of losing oxygen and addition of hydrogen. Oxidizing agent is a substance which experiences reduction and receives electrons. Reducting agent is the substance that experiences oxidation and donates electrons. Here we have an example with lead oxide, which will be the oxidizing agent that will experience the reduction, and magnesium, which is the reducting agent that experiences oxidation. The next reaction is hydrosulfuric acid plus chlorine, where chlorine is the oxidizing agent that undergo the reduction process, and hydrosulfuric acid is the reducting agent that will undergo to the oxidation one. Transfer of electrons. Oxidation involves the loss of electrons. Reduction involves the gain in electrons. Metals are oxidized and its loss of electrons to form cations, and non-metal are reducted and it receives electrons to form anions. Quick exercise for you. Determine the oxidation and reduction process, oxidizing reducting agent that occurs in the reactions below. Now, change in oxidation number. Oxidation is the increase of oxidation number. Reduction is the decrease of the oxidation number. Oxidation number of ions is the same value of the charge of the ion. For example, sodium ion, potassium ion, hydrogen ion is +1, magnesium and calcium is +2, oxygen, sulfur is -2. Oxidation number for atom or molecule in the neutral elements are 0. For example, oxygen, nitrogen, sodium, magnesium, bromine is 0. The total oxidation number for all the atoms is equal to the charge of the ion, if it is an ion. The total oxidation number for all atoms in neutral compound is 0. It's like the charges. The oxidation number of sulfur in magnesium sulfate. We know magnesium is second group, is +2. Oxygen is sixth, -2. Which is the oxidation number of sulfur? We do a quick math. And in the end comes the oxidation number of sulfur will be +6 in order to make equal with 0. Test yourself. Calculate the oxidation number of the following elements. You have some elements here. In each of the cases above, the oxidation number of each element is represented by the value x. The oxidizing agent is the substance that receives electrons, experiences the reduction in the oxidation number. The reducting agent is the substance that loses electrons, experiences then increase the oxidation number. Make sure that you add the electron on the side of the half equation that has the bigger oxidation number. Redox reactions need to shown in the form of half equations, ionic equations. The half equation is iron +2 gives iron +3 plus 1 electron. Bromine plus 2 electrons will give 2 bromine minus. Ion equation will be 2 iron 2 plus bromine will give 2 iron 3 plus 2 bromine minus. Here is an example about the combustion of magnesium in oxygen. Oxygen oxidizes magnesium into magnesium ion. Magnesium releases the electrons to form magnesium ion. The half equation will be magnesium gives magnesium 2 plus 2 electrons. The oxidation number from 0 will come up to +2, which is the oxidation. It releases 2 electrons. Magnesium reduces oxygen into oxide ion. Oxygen atom receives electrons to form oxide ion. Half equation will be O2 plus 2 electrons will give O2 minus, from oxidation number 0 to oxidation number -2, which is the reduction. The change of iron 2 ions to iron 3 ions from iron Fe2 plus to Fe3 plus. This is another example like magnesium and oxygen. The change of iron 3 to iron 2, it's vice versa. The displacement of metal from its salt solution. The element is more electropositive in the equation, the higher the tendency to release electrons to form positive ions. More electropositive oxidized more easily. They act as a reducting agent. The higher the position in the table, it can displace the elements that are lower in the table. For example, the most electropositive is potassium, the least electropositive is gold. Remember, you have to remember the reactivity series. The displacement reaction between zinc and copper sulfate solution. Zinc is more electropositive than copper. Zinc releases 2 electrons to form zinc ion. Zinc reduces copper ion into copper 2 plus to form copper 0. Copper 2 ion oxidizes zinc to form zinc 2 plus. Here is another observation from it for the reaction. The displacement of halogens from halide solutions. Halogen, as we know, are 7th group A. For example, chlorine, bromine, iodine. Can be differentiated by shaking the solution with a little carbon chloride. Halogens are reducted to halide ions. Halogens are oxidizing agent. The more reactive the halogen can displace less reactive halogens from its halide solutions. For example, 7th group A, fluorine is the most reactive. Chlorine, then comes chlorine, bromine, and iodine. The example is chlorine and water react with sodium bromide solution. Thank you.